Greetings, everyone. Welcome to this session on developing a MATLAB code for an economic dispatch problem. Here, I have taken a simple economic dispatch problem without considering the generator limits and the losses. I have also posted a video separately explaining the analytical method of solving the economic dispatch problem. If you want, you can also have a look at it to understand the process, theoretical process clearly. The video link of that session is given in the description box. Now, coming back to the MATLAB session, first we will have a quick recap of the economic dispatch problem, where you can see the left hand side gives you the cost functions. Usually, we will be denoting the cost function in terms of alpha, beta, and gamma. And the power demand is denoted by letter capital PD. The cost function is a function of the power generated by the power plant. Now we'll take a sample problem to understand the code very clearly. Now there are three power plants and C1, C2, C3 are the cost functions of those three power plants respectively. And P1, P2, P3 are nothing but their power generating capacity. PD is the total power demand that has to be satisfied by any of the combinations of these three power plants. Here, the first one indicates the alpha, the second one coefficients indicates the beta, the last coefficient indicates the gamma, and this is your PD. Now coming back to the code, we should know how many power plants are in operating and what are all the cost coefficients, like what is alpha, what is beta, what is gamma for each power plant, and what is the total power demand. So with that note, I am going to write 5 input statements, and the syntax for input statements should be variable equal to input of, and the prompt should be in single quotes. So when you use the command input, it will wait for the user to give the data, and whenever the data is entered by the user be stored into the variable which you are assigning on the left side of the equal to. So here, if you take the first one, you have a line called numbered is equal to input of. Enter the number of power plants considered. So if you are entering number 3, this 3 will be stored into this variable called number. This is the meaning. So first we have to get all these values, no? So first we will get the number of power plants considered. Here we have considered only 3 power plants, so I'm going to enter it as 3. This is over. Next, I want to enter the alpha, beta, and gamma. Now, if you see, there are 3 power plants. That means you'll have 3 alpha values, no? Alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3. So what I can do is I can have all these 3 values in a single variable called alpha, in a single variable called beta, and in a single variable called gamma. So in that way, you have to input all these 3 numbers in the form of a row vector. Row vector means like this. See, for alpha, I should do 500 space 400 space 200. And for beta, you have to enter 5.3 space 5.5 space 5.8. And for gamma, you have to enter like this 0.004, 0.006, 0.009. And the power demand should be 800 megawatts. So let us understand the meaning for this square bracket little more clearly. So now if you take this alpha, we have used only one variable, no, that is alpha. But in alpha, there are 3 numbers. One is 500, another one is 400, another is 200. So which one is called as alpha means if you want to access 500, then that is called as alpha of 1. This one will be calling it as alpha of 2, and this is alpha of 3. Okay, so this will be useful when you are when you're writing a loop statement. Okay, next. Next one is your lambda calculation. So you know that the formula for lambda is directly simple. It is lambda is equal to, it is power demand PD plus summation of beta divided by 2 gamma divided by summation of 1 divided by 2 gamma. So that is equal to, that is equal to, now here this is the formula. So now let's see how to convert this into a code. Now look at this. Now here this lambda is given like this, lambda equal to power demand, that is power demand, plus is there, plus, and this portion, okay, this portion is given by this, and similarly this portion is denoted by this. Okay, now we'll see how to write this. Now the code is, you have to use summation, no, it is sum of, okay, what is numerator, it is beta, so it is beta then divided by 2 times gamma, so 2 into gamma. This is the equivalent code. The only thing which you have to be very clear here is beta is not a single number, it has 3 numbers, it is a row vector. Gamma is also a row vector. If both are vectors, you should not use a simple ordinary division, you have to use a vector division. That means you have to put dot. See, for example, beta has 3 numbers now, 1, 2, 3. Similarly, gamma also has 3 numbers. That is how we have given the inputs. So each one has to be divided. So to do this one, each individual division, I am having this dot symbol here. Okay, right. So that's all. This is for your numerator. And for denominator, this is summation of, it is 1 dot slash 2 into gamma. That's all. Next, we'll go to power generation by each plant. Now, this is the formula. So, right. So, this is formula. The formula is P1. If you take 1, it is P1 is equal to lambda minus beta 1 divided by 2 times gamma 1. So, this will be repeating. No, this logic is same, but only the values are going to same. So, I can put this into a loop. That is why I am going to have this in a loop. So, how to put this into a loop? First, look at this statement. This statement is given here. It is P equal to lambda minus beta divided by 2 into gamma. Here, you can see that I have used letter called beta of I and gamma of I because I want to calculate the individual power generation P1, P2, P3. So as already told you, beta has 3 numbers, gamma has 3 numbers in it. So you have to do it for beta 1, gamma 1 separately, beta 2, gamma 2, beta 3, gamma 3. So for that, I'm using a letter called beta of I. This is what I told you in the beginning here. See, for each one, we have to use alpha 1, alpha 2, alpha 3. That is what we are following it here. Okay, and since we have 3 buses, I have to repeat this for 3 times. That is why I am having the loop like this. I is equal to 1 is to number. That is, I is equal to 1 is to number. 1 is to number means here number of power plants is 3. So it will repeat 3 times. Okay. And here you have a statement called fprintf, and with double quotes, you can see that you have an integer called percentage %d. So if whenever it sees a format string percentage %d, that MATLAB will look for the variable outside the double quotes. So it will look for I. So if I is 1, it will print plant 1. If I is 2, it prints plant 2. If I is 3, it prints plant 3. Okay, so in each statement, whenever as soon as I calculate P1, P2, P3, I am just printing it out. Okay, so now assume that now you can see that the left hand side we have already found out. the value of P1. So this is value of P1 400, P2 is 250, and P3 is 150. So what I'm going to do here is I'm going to have a new line called P sum of I equal to P. So when I is equal to 1, what happens? It becomes P sum of 1 equal to 400. For I is equal to 2, it takes P sum of 2 equal to this one, 250. When I is equal to 3, this becomes P sum of 3 is equal to 150. So on the whole, if you take P sum, it has three numbers in it: 400, 250, and 150. So this is P sum of 1, this is P sum of 2, and this is P sum of 3. Why we are doing this? Because that will be helpful for you, for us to calculate the total fuel cost. Okay. Now coming to this. So for finding total fuel cost, what is the logic? You have to first find out C1. What is C1? C1 is equal to alpha 1 plus beta 1 into P1 plus gamma 1 into P1 square. Look at this. Alpha of 1 plus beta 1 into P1 plus gamma 1 into P1 square. So when I take I is equal to 1, it will be 1, 1, 1, 1, and 1. So what happens? The first looping, it will take 500 plus 5.3 into 400 square plus 0.004 into, because we have just now found out, no, P sum is what? It is 400, 250, and 150. So it is 500 plus 5.3 into 250 plus 0.004 into, sorry. It is 500 plus 5.3 into 400 plus 0.004 into 400 square. Now, when the count increases, when I becomes 2, this becomes 2, 2, 2, 2, and 2. So now it will be the old value plus 400 plus 5.5 into 250 plus 0.006 into 250 square. When it becomes 3, all these value becomes 3. So old value calculated plus 200 plus 5.8 into 150 plus 0.009 into 150 square, and it comes out. And finally, it calculates your fuel cost. That's it. Now let's have a look at the complete code. See, the first step here, I'm going to get the inputs, all the inputs. I am finding out the lambda value here. Here, I am finding out P1, P2, and P3 separately. And here I am finding the fuel cost, total fuel cost. So when I run this, I'll be getting the output. See, I'm giving all the inputs. I'm getting P1, P2, P3, and the total fuel cost. That's it. Thank you.